Okay. Hello, everyone. I'm Dominik. I work at Doc. I'm also the committer in Apache Aries. And today I would like to talk with you about the ports and adapters architecture. First, let's start with the layered architecture. If we look at our software that we are developing, they are often modeled in a layered architecture. We have something in the middle, which depends on nothing. And on top of that, we are building the outer layers and adding the dependencies, which knows only of the things which are deeper in the cycles and not which are more outer for them. And when we look at the operating system, or for example on a Java virtual machine, we could see that this layered architecture could be visible in such cases. Well, according to the programming, when we are building the business application, we have something which could be called the traditional architecture. Here, we could paint it very easily and simply in simplified version as UI, which is it could be graphical UI or any other type of UI which expose our data to outside world, depends on our business logic, and the business logic depends on our data access layer. And such traditional architecture, it's more database centric because you say, no, my model is the most important part in such architecture. But model very often becomes the model of the database. And in such cases, every change in database affects our model, our business model, and could affect even our business rules. So in such situation, business layer depends on the data layer, and probably it shouldn't. If you know the architecture like MVP or MVC, they are very similar to such architecture. If we paint it on the plane on a model of circles, we have our data access layer in the middle of such image, and on top of that we have another components, and especially the business logic, which is depending on the data access layer. And what's wrong with such architecture? I would provide two simple examples. First one, have you ever wanted to replace data layer in your application? You say, what? For what? I have used Hibernate, so why should I even want to change our data access layer? Probably it was true some years ago, but currently we are living in a world where we have more polyglot persistent approach to programming. We are choosing the database which fits better our needs. And if we have microservices, it's very often to replace the technology because it's better for some cases. So replacing relational database with some document database like Mongo or Graph database or service available via HTTP is something which becomes more and more popular. And using only the Hibernate, for example, as a data access layer, is impossible to replace such data access layer. And so we end with a Hibernate on bottom of our cake, on top of which we are building another layers. And if you want to replace the bottom layer, it's just impossible in such situation. Another example that I want to mention is that, for example, let's imagine we have some kind of entity where we have a field, for example, list of orders. Of course, it's entity. So we are adding the annotations connected with Hibernate with some JPA framework, which tell the database, the framework, how to connect with database, which column take, and how to join, for example, entities with each other. Of course, it's according to our data access layer, but because such object becomes our model, we could also have opportunity to add some validation, and we often add such validation to this object. So, for example, it's easier to add only some annotation from GSR. Next, we often want to expose it via some service. In the past, we have been doing a lot of SOAP services, and so we could expose the XML, make our entity as a JAX-B object, or now we are changing to we are moving to the RESTful architecture, where we are using JSONs in most cases. So we also could add such annotations to our entity. And with such approach, we could end with a very big entity, which we could call our business model, where only the two lines, one defining the class and one defining the fields. And of course, we have a lot more fields below. But we have a lot of stuff connected with the infrastructure, how our code fit to this infrastructure. And we have very low information, or it's very hidden. Where is our business code in such big class? So we could end with a big ball of math where we clamp another part of the math to such entity and make it something like a God object. Is there any solution to such problem, to such approach, to such architecture? Of course, if you look at the simplified view of the architecture, and the problem is with the bottom arrow. If we replace the such arrow with the arrow with opposite direction, we could make our business logic the most important part, and something which will be the kernel of all our things connected in our applications. Of course, we have to be sure that UI really depends on business logic, and there are no information that should be in business logic, but in some because of some bad situation in the past, they were in the UI layer. Of course, it's very simplified. So if we add another components which could talk with our domain, we have to be sure that our domain doesn't have to know about all these components, and they are only connecting to our business domain. And the solution, such architecture, is named port and adapters. Ports and adapters architecture is also well known as a hexagonal architecture, and it's also the layered architecture. It was introduced by Alice Coburn in 2005, so it was a long time ago. The idea of this architecture is that our domain depends on nothing, and we are separated from external world in some way. So the changes in external world doesn't affect our domain, of course, unless it change our business. What are the parts of this architecture? We have here a domain, of course. We have ports, which also the part of domain, and from the architecture point of view, this specific architecture point of view, ports are the most important part, because the boundary, the border around our domain is very important here. Here we have we could divide our ports into the primary and secondary ports, and our adapters are also correlated with the ports and also divided into the primary and secondary adapters. From Alistair Coburn article, there's a great image, but not in very good resolution, I think, where we have application, which means our domain, the most important part of our application in the middle. Around that, we have a boundary, which is the border between application, between our domain, and the adapters which connects to the external world, for example, with database, some sensors, or something like that. Our domain. Domain is the place where all business logic is here, yeah? And it depends, as I said before, on nothing. And we can also only accessing or access out this and go out from such a domain via the ports. The domain should be framework or even the library agnostic, and only one thing that we need is dependency inversion frameworks, whatever we want to inject our dependencies, because we have to provide the adapters to our domain in some way that will be abstract from the domain point of view. And our classes, our objects in domain should be plain old Java object or whatever language you are using in your project. As a disclaimer, plain old Java object, it doesn't mean that this is the Java bean. It's something different. Plain old Java object are the classes or just the object that not extend or implement any pre-specified class or interface and shouldn't even have any annotation provided from external framework or library. Ports are part of the domain, and they are the contract that our domain exposed to external world. So we are defining the boundary of the bounded context and use cases available in our domain, and we cannot exceed and enter domain without them. If they have a good level of abstraction, then they prevent us from the noise from external world, and it should be the true in each our application. As I said, ports are divided into primary and secondary. Primary ports are triggers in our application. They trigger some operation on our domain, and interfaces, for example, interfaces in Java world, there are interfaces implemented by our domain. So it's API of our domain exposed to external world. And we are wiring such API in the primary adapters to perform some operation on our domain. Primary ports has several names. One of the best, in my opinion, is the last one, but it's not very well known. It's offering. It means our domain offers such functions to external users. When we say users, I mean the adapters that want to join us. We have on the other side the secondary ports, and they are the SPI of our domain because we are defining in the domain the interfaces or some abstractions that we want to be provided by other components, and it means the secondary adapters. And we are exiting the domain to call the external world via them. They also have several names. One of the best is required, in my opinion. It means our domain to perform its operation, its functions, needs something from external, required such thing from external world. Adapters, the last part of this architecture, if you they are communicating with external world. They are receiving the request or sends the request to the external world. There should be no business logic. And if you read a book about design patterns by Gang of Four, then this is the perfect implementation of adapter. It should be the perfect implementation of such of adapter pattern from this book. Adapters are divided into primary and secondary. Primary adapters are using the primary ports to convert the request from incoming word, from word, for example, from our REST endpoints to our domain on whatever we want to call something on our domain. And there is a lot of examples. Let's move forward. Secondary adapters, they are converting domain request to the external world. So, for example, we receive the information that domain want to send an event, and for example, we could use the JMS adapter, which knows how JMS work or how AMQP works, to send such event to specific broker or something like that. And there is a lot of examples of such adapters in our real life. So our application written in ports adapter architecture have a domain with some ports as a point that have been filled by something else, by some plugins, which as a whole make our application very usable and provide all the business features that we want. But we are focusing the most on the central part, on the domain of our application. Okay, what are the advantages of such approach? First, the most important feature is that we are domain-centric. We can concentrate on the domain and the language that we could use in our domain because of the creation of the boundary and creation of the having the separation between us and external world make our domain very clear, because we can use ubiquitous language that is common for us and our customer in such domain. In such situation, adapters could be really the implementation application details, so they should be only aware of the technological choices under the hood. For example, how to handle nulls and empty string in Oracle, not any business condition here. With such architecture, we have very good testability because our domain could be tested only with unit tests. So we could write a lot of such tests which could do something on our domain. And even if they are written in a good framework, for example, like spoke in JVM Word, we could expose such tests, provide such tests to our customer. And because of usage of ubiquitous language, the customer probably will understand what you are talking about in your test. It's easy to achieve 100% coverage in your domain, and it doesn't mean that you want to cover all the lines. You want to cover all the cases in your domain, in your application. And if you look at the adapters, of course, they have to be tested with the integration test, because probably they have to connect to the database, have some Docker with the Kafka broker or something like that to test if this connection is working. With such architecture, we have very good replaceability and adaptability because external world could change, and we want to change our application according to these changes, but not touching the domain code when it's not needed. So, for example, it's very easy to replace existing secondary adapters, because one day we are talking with the database, next day we can talk with some other service. You can say it cannot happen very easily. I have such situation where we replaced such a database with a decision of one. There was a decision one day, and second day we have the working solution working on another type of database. We have Swift change from the Mongo database to Postgres database because we need transaction, and it was not provided in the old version of Mongo that we had. And another thing that we could do with such architecture, we could add new primary adapter very quickly, so it makes our time to market very short, because one day we want to expose on the SOAP, everything via the SOAP API, and next day we want to expose, for example, something for REST, and we know that all our business rules are kept in our domain. So writing such code that exposes only some data from such domain is very easy. We have timelessness because, of course, frameworks library could or even always changes, and we have our domain is changing only when our business is changing, when the business rules are changing. We have simplicity of such solution because it's very easy to learn such architecture, and if you know how this architecture works, it's very easy. It has only 3 main parts, and if you write a lot of your services or modules of microservices in such a way, then whatever project you will open, you will see that it works in the same way. You know where is domain code, you know where are the details from the technical perspective, and you know probably where to add feature or fix some feature. If you want to write in a DDD manner, then in my opinion, you cannot do this with good ports and adapters architecture, because without ports and adapters, you are not preventing your application from domain leaks or logic leaks from your domain, but also you could be exposed for a very big noise from external world, which could affect your domain. If you want to write in a CQRS manner, then ports and adapters architecture is great for command part of this approach. Of course, there are also the disadvantages of such technology. It's not easy to start technically, because you have to create much more classes and interfaces, for example, in Java. There could be a problem because you are creating the interface only with one implementation, for example, in adapter or in our domain. And it could be a problem because you could not extract good abstraction from your classes, and your interfaces, your ports becomes very tight to the implementation for them. It's have to be designed in a very good way. It's not simple to use the external framework or library, because you should use them only in the adapters, not in our domain. And it's sometimes very difficult to tell someone just create this separate class for that. Don't do this in this place. And it brings us to the another disadvantage. It's not easy to start mentally, because you have to convince your teammates to work in such architecture. Good word for that is the word experiment, because you can say, okay, we'll try this approach. If it works, then probably we stay with the architecture. If not, probably you have touched only small part of your application or created new microservice, and it will probably be easy to just switch to the another approach. But in most cases, it will be something which will be eye-opening for writing good architecture. And also, discipline is something that is must-have. Yeah, I will show the another approach which helps us in it. But at the beginning, we need some discipline in our team. And for example, do not try to stick with the old approach where let's do a quick fix and put only the code to the external system here, because it will be easier. We don't want to go to the easier solution. We want to go to the best solution. Okay. I have a question. Can you?
Yes, there is a question. The question is in Polish, so I will say that in Polish. Gdzie w takiej architekturze są granice transakcji? Czy porty, adaptery powinny być świadome istnienia potencjalnych zewnętrznych transakcji?
Okay, so where should be transactions in this approach? We have one, for example, on the example of my service that I have mentioned before, where we need the transaction in Postgres. We have created the transaction in our primary adapter. Here we set up, okay, we want to perform such operation our domain, and they should be in the transaction, and transaction was spread also to the secondary adapters under the hood. So I think it is the answer for your question. Okay, is there another question? Thank you. Okay. Okay. Another disadvantage is we could have a problem with performance, because we are doing a lot of translation between layers and going through some ports, and in such situation the conversion between objects could be expensive, but it don't have to be. Sometimes it's better to work for better correctness of our solution, not the better performance. Yeah, first correctness, then performance. And our domain should it be or not aware of the batches, or should we only process the elements one by one? It's also the question according to the performance. Such architecture could be an overhead for small application, because if we, for example, set up my new microservice with such architecture, and there should be probably 1, 2, 3 classes, and then building it on top of ports and adapters architecture could be too much for our microservice. Sometimes it's premature optimization. There is also the question how to implement, and it's also the disadvantage because there is not a lot of good resources. Currently, it's changing, and there are some more and more such resources. But I remember time when we started with such approach, and it was there is no much data about such architecture, and of course, because you are working on your domain, on your specific domain, then it depends on you and depends on your problem. And based on the advantages and disadvantages, when to use such architecture, The best answer, in my opinion, is when you have a long-lived business application and this application have complex behavior. It's perfect then to use the ports and adapters architecture. On the other side, when you have a simple pipe that's just take the data from the JMS message and put it on some and send it via some REST service, there is no point to use ports and adapters architecture. The same if you are doing the query part of CQRS, it just take data from the database and put it on the screen. Don't convert it via some layers of DTOs, and it's not relevant for the for your application. When you're doing a CRUD for database without any additional logic, it's also not necessary and not bad approach to use this architecture. When you write own framework or own library, it's also, you shouldn't use ports and adapters here. This is the architecture only of business applications. Okay, how to implement it? As I said before, it's up to you. But depending on the language that you are using, for example, in Java or C#, we could write our ports as interfaces. In C, C++, we could use the H files, and there is another approach depending on the languages. And for example, I want to show you our packaging, because packaging is the most important part where we could see the architecture in our application. For example, here, we have our packaging. We have domain. Domain contains some process where we process everything in our domain, and we have ports divided. Okay, and we have incoming and outgoing ports, and they are implemented by incoming adapters depending on the technology that we want to use, and outgoing adapters also depending on the technology. Of course, we don't have to stick to the technology. We could, for example, name the packages after some system that we are connected to. Another packaging approach, maybe more simplified, is that in our domain we have, of course, model and process, which are the core of our domain. We have API and SPI of such domain, where are the ports. And we have API, also could be named entry point, where we have the primary adapters. And in adapters package, we have the secondary adapters of our application. If we need to create some stuff which is connected with the whole application, for example, like definition of logging, we could put it in the infrastructure package. Another our rules, and maybe some violation of these rules, of the architecture rules, we have the conditional in each conditional in our adapters should be really the implementation detail. So we stick to this rule from the architecture. We allow to annotate the dependency injection annotations in our domain. It was the violation of the rule, but it was easier because we couldn't use Spring. So in specific example, for specific example that I have mentioned before, we have to use our framework, because instead of that, we have to use the XML files. We are trying not to name our interface beginning with the I and name classes with the imp suffix, because this is the sign of lack of good abstraction. And we have the review and discipline to keep everything as we want. And here it's worth mentioning that currently in Java, we have something which is called architecture test and arcunit. Here, we could define that no class in the domain and package no class in the domain package could depend on persistence package. The same, for example, with the web. But it's worth mention that it's very strict. There are very strict rules, and when you do some trade-off, probably you have to do an exception to your test. Also, according to our ports, primary ports of our domain were divided by the use case of this domain. Secondary ports were grouped by operations which are working probably on the same resource. We will see that in the example. We could exchange the DTOs, which are preferably immutable, and have primitive types wrapped by some other entities, and I will see it in a moment. And there was a question. Can I hear it now?
Yes, actually there was one question and it was already answered, but there is another question. So one question, the one that was answered was about class separation in packages, and you have covered that in the presentation. And there is another question. This one is in Polish. Ono jest połączone z poprzednim pytaniem odnośnie transakcji. Przeczytam je. Doprecyzowując rozpięcie transakcji między dwa wywołania portu adaptera jest niemożliwe sprzeczne z architekturą. Czyli, że rozpięcie transakcji między dwa wywołania portu adaptera jest niemożliwe sprzeczne z architekturą. To jest pytanie.
No, I don't understand this question. If I understand you correctly, you want in one transaction calls two methods on two separated primary ports of your application. No, it's not. It is correct in this architecture, but we can talk about that offline because.
So Dominik, please join us after the presentation on the Discord channel. There will be for sure more questions to you.
Yeah, I will be available there. So yeah, see you then. Okay. Example of such architecture, because it's the best to work on the real example on code. For example, we want to create a task management domain, and here we want to offer some use case. For example, adding task, assigning task, completing task. On the other side, we want from the external world to have some task repository or even publisher and user repository to perform all the operation in our domain. It was defined during some analysis. Okay, first primary ports. We have the interface, for example, add task, and here we have the one method add new task, and it returns the task ID. New task is a value object. Our task ID and user ID are wrappers, for example, for very meaningful IDs in our application. Assign task and complete task interfaces are very similar to add task, and it's just plain interfaces with our specific domain types. In our domain, we want to create, for example, one service, task service, which implements all our interfaces. It's small domain, so it's good enough to have them in one place. We want to inject the task repository, user repository, and event publisher, and how to write the code that we have to implement it because of the interfaces. It could be a good homework for you. We have the secondary ports, and here we start with the user repository. Here we have only one method. Does the user exist or not? We don't have the whole information, how to take the user from the database, how to save the user in the database. No, from the perspective of this domain, we only need the information, does it exist or not? We have named it repository, but it could be something else. We have a task repository, and such task repository could have the operation corresponding with the actions that we want to perform on our domains. For example, we have the method add, find, maybe change assigning, change status, but it's not very. We are very stick to our domain implementation. So it's better to write such a repository in a way that we have, for example, only two methods in such repository: save and find, nothing more. We have also the event publisher. It could be stick to the specific events that our domain could expose to external world, but maybe it's easier to have only one method where we could publish the task event. What is task event? It could be the interface. It could be the abstract class, for example. If you want to combine the task repository and event publisher, we could create, for example, task event store, which is helpful for event sourcing, where we could publish list of events as a result of our business operation. And when we want to take the task from the database, we ask with task ID, and we receive the list of event and rebuild the whole task in our domain. Another topic that I want to mention is multiple domains. Here, if you have domain A, which wants to call domain B, then domain A have to go through its secondary ports to the secondary adapters and go to the primary adapters of domain B and primary ports of domain B and hit the domain B. It could be very, very big when you compare it to many microservices or many domains which want to talk with each other. And in such situation, it looks like honeycomb, and it even named after that as a honeycomb architecture. But according to such multiple domains, I want to mention something which is called multiple domain in the military zone. And it means that we could create our service or our monolith, modular monolith, in such way that in the middle, we have the classes which we know that we are working in ubiquitous language, and we are safe here to, for example, not go through the adapters to external world, but call each other more directly. Of course, if you want to go to the external world, we have to go through some adapters layer. There is a problem if we are working with such the military zone that our domain A or subdomain A in such case wants to ask the domain B, then it's calling the primary ports of another domain. And in such situation, we are very coupled to each other. Both subdomains are coupled to each other. And if we look at the packages, we could see that, for example, if you have our order domain, we could have API and SPI for as usual in the ports adapters architecture. But instead of calling only the SPI from our processes, we could call API of our domain. Yeah, and it works okay. Until you have to divide such big modular monolith to small pieces. So if you know that probably you will have to chop it in some another applications, then it's you should be aware that it could be problem if you do this approach. Okay, it's not always that you have the greenfield project. Sometimes you have some brownfield project where there is a lot of legacy code in your application, but personal adapters is something that could be the game changer for your application and could help you. So let's imagine that we have very old application which takes the request from the command line, calls the service A, and service A is talking with the depends on the database and calls something in the database. Let's imagine that we add new feature to such project, and here, for example, we want to create service B. We create also the port of such request of such domain, subdomain, or service B, and next, we also create the secondary ports for such domain, and we make our CLI calls our primary ports, and our database extend our secondary ports. And it's in such situation we are ended with this right side. I would call it part of our architecture, which are in ports and adapters manner, and the old part, which is still in your old previous implementation architecture. We could add a new primary adapter to your to such old application. For example, every time we are doing all the stuff via the command line, now we want to expose our operation via the REST. It's very easy because now we only have to create the good abstraction of our domain in the interface or the port A here, and then we cannot just implement it probably in service A, because there could be a problem that our CLI could some knowledge about how our domain works. So first, we have to move some knowledge from CLI to service A to make service A really containing all the domain of our application, of our request, for example, or some feature that we want to expose via the REST. Then we could make our service to implement our created boundary created port. And then we could move our command line component to use our interface on our domain, not to call the service A directly. There are some modifications that I want to quickly mention during this presentation. There could be a domain without own domain objects and DTOs. Its approach to use such architecture when we have very complex adapters. They are converting data from, for example, one REST calls to some SOAP calls, and there could be really complex logic, and there could be not just mapping that we could create in some tool like Mapforce or something like that. And we have to have some better knowledge how to do this correctly, and especially when this mapping is changing very rapidly. We could do this without defining all the additional DTOs, additional objects in our domain, but use the objects that are provided by the existing adapters, for example. We could have our domain DTOs or domain objects, which have some external parts. So for example, because mapping input could be expensive for us, then we could put such data, for example, in some context data, some original request field in our DTOs, and do not map them in our code. Maybe create only some abstraction on top of that, and going through such domain, pass such object. Of course, there is a problem if you want to, for example, test it only with unit test. It could be problem because some of such objects, like requests, could be created only by the library that is under the hood. We could pass the context between adapters, and it's something which is also connected with the transactions. If you have in primary adapter, you receive some context data, for example, like credentials or audit data, and or for example, you want to create the transaction here. You can do this. Our domain don't have to be aware of that unless it's necessary for the domain, and in most cases it's unnecessary for the domain does the transaction commit or rollback, yeah, and the exception could be catch on the another level. And in such situation, on the other side of our application, we have secondary ports, adapters, I'm sorry, where they could use those data which were hidden, for example, in some thread locals or something like that. We could also create the ports and adapters architecture in such manner that our ports contain only the interfaces without any DTOs. It will be more abstract for our users, for the users that will implement our adapters. But of course, it could be a problem when we want to use it in some test, yeah, because we have to create dummy implementation of such DTOs objects. Another thing that I want to mention in this presentation, we are going to the end. There is another architectures that are very similar. We have the Onion architecture. It was crafted by Jeffrey Palermo in 2008. And we have also the Clean architecture crafted by Uncle Bob Martin in 2012. If you want to compare them, then this is the old image of ports and adapters architecture. We have only applications, some boundary, and adapters. And for example, in Onion architecture, the domain, the code in the middle was defined in more specific way. We have more parts, more layers inside such application. The same with the Clean architecture from Uncle Bob book, if I remember correctly, or article. And here you have also the use case entities which are inside our domain. Okay, to summary, the hexagonal architecture is an approach to writing the architecture that helps us to focus on our business goals, on our business code, on the parts that are the most important for our customers, and not being tight and don't care about technical frameworks, technical issue, the technology, or infrastructure things that we could choose, for example, later in our project. We don't have to, for example, stick to them just now. Okay, that's all from me. If you have a question, this is the perfect moment.